This video is about electrophilic substitution on a benzene. Okay, why electrophilic? Because benzene is rich with electrons in the middle here because of the pi electrons. Here, rich with electrons. There's high electron density right in the middle of the benzene ring. So an electrophile will love this part of the ring. To initiate this reaction, we'll need the electrophile first. So what's going to happen is the nitric acid and the sulfuric acid will initiate this reaction by forming an NO2 plus. So this is what we need. And there's going to be 2 HSO4 negative, and it'll form a H3O plus. That electron-rich area is going to be so attracted to this electrophile. Okay, so in detail, what does this benzene ring actually look like? So if I were to draw it in full, each of them is bonded to 1 hydrogen. Okay, this happens in a resonance, but I'm just going to draw one version of it. Can you see that all the carbons here already have 4 bonds? And it's bonded to only 3 things. So one carbon is bonded to a H, a C, and another C. So this is a trigonal planar. Okay, so what happens is, when this attraction happens, this ring, so we always combine these 3 double bonds and we put them as like a ring in the middle. Okay, so what happens is that is disturbed when the NO2 comes near. Keep in mind that all these has a H bonded to it. So I'm just going to make it clear and draw the H there. They all have a H. And this has a H as well. But now it also has an NO2 here. Now, where did the positive charge go? It went to the other side. So 5 of these carbons will share that positive charge. And this is the only carbon that has 4 bonds. You know, a carbon that has 4 bonds, it doesn't have any charge. So that's the only one that has 4 separate bonds. The others still have that 3 bonds, but then this system has been disturbed. It's broken now. Okay, so in the next step, what's going to happen is the H will come out empty-handed and return those electrons to complete that system again, so that it'll form a full circle here. So now all of these are still H, but that has been replaced or substituted by an NO2. So that's why it's called an electrophilic substitution reaction. Now, where did that H go? It's actually taken by this HSO4. HSO4 negative is going to combine with that H and comes right out as a H2SO4. That's a catalyst because it comes out the same as how it went in. So this is an electrophilic substitution reaction. The H was replaced by an NO2. We can actually do the same for Cl2 with AlCl3. We just need the electrophile. So Cl2 plus AlCl3, we can get an electrophile plus AlCl4 negative. AlCl3 has an empty orbital. That's why it can form the AlCl4 by accepting a lone pair of electrons so that the Cl plus can be formed. Would look exactly the same as the one I drew before. The Cl positive loves the electron rich region of the benzene ring, and it's going to form this intermediate that looks kind of weird. The Cl, the H here, and I'm going to redraw that. The Cl, the H will return the electrons to recover the original system, and now H has been replaced by a Cl. Who took the H? Must have been this. So what's going to be formed is the Cl comes right out and join the H to form a HCl, and the AlCl3 is recovered. It's just a catalyst.